If you've ever watched an episode of Star Trek or The Big Bang Theory, then you know that physics can be made accessible to the masses in a fun way. Our favorite sci-fi and comedy writers may not get every detail right, but they do spark our interest in the weirder aspects of scientific theories. Today, we're going to talk about 10 real mysteries that physics has yet to explain. From alien communication to time travel to gushing faucets, we'll try to make these mysteries understandable for everyone. You may even want to explore these topics further on your own. After all, there are $1 million prizes waiting for the people who solve some cosmic puzzles. You'll probably get a Nobel Prize and change the world, too.
Number 10. Where do ultra-high energy cosmic rays come from?
Our atmosphere is constantly being hit by particles from outer space with high energies. These are called cosmic rays. Although they don't pose much harm to humans, they have fascinated physicists. Observing cosmic rays has taught us a lot about astrophysics and particle physics. But there are the ones with the most energy that are mysterious to this day. In 1962, at the Volcano Ranch experiment, Dr. John D. Lindsley and Livio Scarsi saw something incredible, an ultra-high energy cosmic ray with an energy of more than 16 joules. To give you some perspective, 1 joule is roughly the energy it takes to lift an apple from the floor onto a table. All of that energy is concentrated, though, in a particle 100 million billion times smaller than the apple. That means that it's traveling very close to the speed of light. Physicists don't yet know how these particles get this incredible amount of energy. Some theories include the idea that they might come from supernovae, when stars explode at the end of their lives. The particles may also be accelerated in the disks of collapsing matter that form around black holes.
Number 9. Was our universe dominated by inflation?
The universe is amazingly flat on large scales. This is something called the cosmological principle, the idea that, wherever you go in the universe, there's roughly the same amount of stuff on average. But the theory of the Big Bang suggests that, at the very earliest times, there must have been some big differences in density in the early universe. So it was much lumpier than our universe is today. The theory of inflation suggests that the universe we see today comes from a tiny volume of the early universe. This tiny volume suddenly and rapidly expanded far faster than the universe is expanding today. Just like if you drew on a balloon and then filled it with air, inflation stretched out all the lumps in the early universe and explains why we have a fairly flat universe where conditions are similar wherever you go today. Although this explains a lot about what we see, physicists still don't know what caused inflation. Details of what was happening during this inflation are also sketchy. A better understanding of this era could tell us a lot about the universe as it is today.
Number 8. Can we find dark energy in dark matter?
It's an amazing fact. Only around 5% of the universe consists of the matter that we can see. Physicists noticed some decades ago that the stars on the outer edges of galaxies were orbiting around the center of those galaxies faster than predicted. To explain this, the scientists suggested that there might be some unseen dark matter in those galaxies that caused the stars to rotate more quickly. After this, observations of the expanding universe led physicists to conclude that there must be a lot more dark matter out there, 5 times as much as the matter we can see. Alongside this, we know that the expansion of the universe is actually accelerating. This is strange because we expect the gravitational pull of matter, both light and dark, to slow down the expansion of the universe. Combine this with the fact that the universe is flat space-time, overall, is not curved, and cosmologists need an explanation for something that balances the gravitational attraction of matter. Dark energy is the solution. Most of the energy in the universe can't be locked up in matter, but instead, it's driving the expansion of the universe. Physicists believe that at least 70% of the universe's energy is in the form of dark energy. Yet to this day, the particles that make up dark matter and the field that makes up dark energy have not been directly observed in the lab. Observing dark matter is difficult because it doesn't interact with light, which is how observations are usually made. But physicists are hopeful that dark matter particles might be produced in the Large Hadron Collider, where they could be studied. It could turn out that dark matter particles are heavier than anything the LHC can produce, in which case it might remain a mystery for a much longer time. Dark energy is supported by many different observations of the universe, but it's still deeply mysterious. In a very real sense, it may be that space just likes to expand and we can only see it expanding when we look at very large scales. Or maybe the dark matter and dark energy explanations are incorrect, and an entirely new theory is needed. But it would have to explain everything we see better than the current theory before physicists will adopt it. Even so, it's incredible to think that we may know very little about 95% of the universe.
Number 7. What's at the heart of a black hole?
Black holes are some of the most celebrated objects in astrophysics. We can describe them as regions of space-time with such strong gravitational fields that even light cannot escape. Ever since Albert Einstein showed that gravity bends space and time with his theory of general relativity, we have known that light is not immune to gravitational effects. In fact, Einstein's theory was proved during a solar eclipse that demonstrated the sun's gravity was deflecting distant rays from far-off stars. Since then, many black holes have been observed, including a huge, supermassive one at the heart of our own galaxy. But the mystery of what occurs at the heart of a black hole is still unsolved. Some physicists thought that there might be a singularity, a point of infinite density with some mass concentrated down into an infinitely small space. It's difficult to imagine. Worse yet, any singularity leads to a black hole in this theory, so there's no way we could observe a singularity directly. There is still debate about whether information is lost inside black holes. They absorb particles and radiation and emit Hawking radiation, but the Hawking radiation doesn't seem to contain any further information about what's occurring inside the black hole. Some information about the particles that fall beyond the event horizon into the black hole seems to be lost. The fact that it seems impossible, at least at the moment, to understand what is at the heart of black holes has made sci-fi authors speculate for decades about whether they could contain different universes or be used for teleportation or time travel. Since being absorbed by a black hole involves being stretched into a string of atoms, we're not volunteering to venture inside and find out.
Number 6. Is there intelligent life out there?
People have been dreaming of aliens for as long as they've looked up at the night sky and wondered what might exist out there. But in recent decades, we have discovered plenty of tantalizing pieces of evidence. For a start, planets are far more common than people originally thought, with most stars having a planetary system. We also know that the time gap between our planet becoming habitable and life emerging on it was quite small. Does this suggest that life is likely to form? If so, we have the famous Fermi paradox. Why haven't we communicated with aliens yet? There are plenty of solutions to the Fermi paradox, ranging from the wild to the more sad and mundane. It really shows the difficulty of reaching any good scientific conclusions when you only have one data point, us. We know that intelligent life evolved on this planet, which means that it can happen. But we can't know if we just got incredibly lucky. Or maybe there's something special about our planet that makes it extremely rare but suitable for hosting life. Or perhaps the probability of life beginning is extremely low, so there are few, if any, alien civilizations out there. Astronomer Frank Drake put together his Drake equation as a way of looking at all the different aspects of this problem. Each of the terms represents a reason why we may not be communicating with intelligent life. Perhaps life is common, but intelligent life is rare. Maybe, after a while, all civilizations decide against communicating with other life forms. They're out there, but they don't want to talk to us. Or, chillingly, maybe this shows that many alien civilizations destroy themselves shortly after becoming technologically advanced enough to communicate. We can worry about this happening on Earth with nuclear weapons or out-of-control life. It's even been suggested that the lack of communication from aliens is proof that the world was created either by a god or as part of a computer simulation. This would explain why there's only us. The cosmic gamers are playing in single-player mode. The reality is that we haven't been looking for all that long, and space is unimaginably vast. Signals can easily get lost, and an alien civilization would have to send a powerful radio signal for us to pick it up. But it's exciting to think that the discovery of an alien civilization could happen tomorrow and change our understanding of the universe forever.